Hello, we are going to review Chapter 2 in this video. So let me just kind of give you an overlook here. What we're going to do is start by solving equations, then we're going to move on to solving just regular inequalities. We'll go on to absolute value equations, and then we'll go on to absolute value inequalities. After that, we'll take a look at a graph, writing a function, graphing it, and using that graph to solve for given inputs and outputs. We'll evaluate a function for given input. Simplify absolute value expressions, and then we'll be completing this table, which is identifying independent and dependent quantities and defining variables. So I'll start off with the solving just equations. In this first one, what I'm going to do is use the distributive property. So what that means is that 3 is being multiplied by both of these quantities. 3 times x is 3x. 3 times negative 1 is negative 3. Bring down the plus 7, and then set it equal to 15. Next thing we can do, take a look at all three of these terms. What we want to do is combine our like terms. The reason for that is because all of this is on the same side of the equal sign. So what I'm going to do is combine these two. So I get 3x, and then that's going to simplify to positive 4. And then we're going to set that equal to 15 again. Now what we can do is balance this equation by subtracting 4 on both sides. And that's going to get rid of the 4 here. So I have 3x equals 11. And then the last step, I have 3 times x, so we're going to have to divide both sides by 3. So x is going to end up being 11 over 3, which, if we wanted to write that as a decimal, we could. It comes out to 3.67. Next one, my variables on the right-hand side, it doesn't change anything. We're still going to use our inverse order of operations here. I have a 2x minus 5 here, so what you want to do is take the inverse of subtraction, which is to add. So I'm going to add 5 to both sides, and then just watch your signs. Negative 17 plus 5 is negative 12. I'm going to bring down the 2x on the right-hand side. So now what I want to do is get x by itself, divide both sides by 2. Negative 12 divided by positive 2 is negative 6. And then x would be all by itself, so that means x equals negative 6. So for any of these, if you wanted to check your answer, you just substitute your answer right back in for the variable. Solving regular linear inequalities for these next couple, we're going to solve them the same exact way, except there might be a couple rules that pop up here. So I'm going to solve these, and I'll graph the solutions on the number line as well. In this first example, we're going to solve this just like an equation. You're going to want to add 4 to both sides first, bring down the negative 3x, my inequality of less than or equal to, and then negative 9 plus 4 is negative 5. So then what I want to do is get x by itself. In order to do that, I'm going to have to divide both sides by negative 3. But when you divide both sides by a negative, or whenever you divide by a negative coefficient, if you are multiplying or dividing by a negative number in front of the variable, you need to flip the inequality. So this becomes greater than or equal to, and then negative divided by a negative is a positive, and I can leave it as 5 over 3. I could also express this as a decimal, which would be 1.67. So if I'm going to graph this on a number line, I'll just do it over here. Let's pretend that this is 0, and that this is 1, and that this is 2. What 1.67 would be is between 1 and 2. I'm going to put a circle above that. Since it's greater than or equal to, you're going to need to shade in that circle. What that means is that 1.67 is part of my solution, as well as all the numbers that are greater than it. So you would have a closed dot because the or equal to part, and then we're shading to the right. Because it's all the numbers that are greater than or equal to that. So what I'm going to do is just kind of wipe the graph, then I'll keep my work there, and now I'll do the next problem. I'm going to solve this just like I did the problem for equations, but now it's an inequality. Distribute 2 times x is 2x, plus 2 times 2 is 4, minus 4 is greater than 8. Combine your like terms here. I have a positive 4, and then I have a minus 4. So these are actually just going to cancel out to 0, and you'll be left with 2x is greater than 8. And now if you divide both sides by 2, you're going to end up with x is greater than 4. So if I put a 0 here, I would go 4 spots to the right, and this would be my 4. Now since it's only greater than, it's not greater than or equal to, what that means is 4 is not part of your solution. So you need to put an open dot there, but all the numbers that are greater than 4 are part of your solution. So if you wanted to check your answers for inequalities, you could just substitute any value that's past 4 here, any number greater than 4. So if I were to take 10 and substitute 10 in for here, 10 plus 2 would be 12. 12 times the 2 is 24, and 24 minus 4 would be 20. So is 20 greater than 8? Yes. So what that means is that all these numbers, again, greater than 4 are part of our solution. The next ones are absolute value equations. So absolute value was that distance that a number is away from 0. So for these problems, we are going to have two answers. What I'm going to do first here is get my absolute value quantity all by itself by subtracting 2 first. So I get the absolute value of x minus 4 equals 6 minus 2, which is 4. And now what we're going to do is break this up into two equations. I'm going to have x minus 4 equals 4, and I'm going to have x minus 4 equals negative 4. And solve both of these. For this first one, I'm going to have to add, why did I do that? I'm going to have to add 4 to both sides. So I end up with x equals 8. And for this one, if you were to add 4 to both sides, you have negative 4 plus 4, and that is going to be 0. With this next one, notice I have 2 times this whole quantity. So I do not want to distribute, but instead we can divide both sides by 2 in order to get rid of that 2. So notice again the difference between A and B. In A we were adding 2, so I used subtraction to get rid of it. In part B we're multiplying the absolute value by 2, so I'm going to divide both sides by 2 to get it by itself. And I have x minus 1 equals 0 divided by 2, which is 0. And then at the very end here, just take x minus 1 and set it equal to 0. You can only have one answer for this because if you think about it from the very beginning of the problem, it's really saying how many numbers are 0 units away from 0. And that's only one number. There's only one number that's 0 units away from 0, and that's 0. So we're only going to have one answer for this problem. I'm going to have to add 1 to both sides here, and you end up with x equals positive 1. For part C, think about how many numbers are negative 4 units away from 0. Well, if I draw a number line and I put 0 here, well, if I go 4 units to the right, that's positive 4 units away. If I go 4 units to the left, that's still positive 4 units away from 0. You're just at negative 4. So distance is always positive. So this is saying if you were to take some number and add 2 and then take the absolute value of that number, you would get a negative. But that should sound a little fishy to you because you can't take the absolute value of a number and get a negative. So what that means is that there is no solution. So right away, before you even starting to solve this problem, realize that you are taking an absolute value and you are setting it equal to a negative. And since absolute value, whatever comes out of that has to be a positive number, there's no way that it can be negative. So that would be a no solution. So what we're going to do is move on to absolute value inequalities for these next ones. So for this first one here, what we're going to want to do is divide both sides by 2 first. And that's going to get my absolute value quantity by itself. So I get the absolute value of x minus 2 is greater than or equal to 2.5. So then now we're going to break this up into 2 separate absolute value quantities. I'm going to have x minus 2 is greater than or equal to 2.5. And then my other inequality is going to be x minus 2. And you have to flip the inequality and change the sign. So negative 2.5. And then we're just going to solve both of these. So I'm going to add 2 here. And that's going to end up with x is greater than or equal to 4.5. And I'm also going to have to add 2 here. And then this one's going to be x is less than or equal to negative 0.5. So I'll make a number line below this. Let's say that this is negative 2, negative 1. This would be 0, 1, 2, 3, 4, 5, 6. So what I'm going to do is shade these separately. So this first one is x is greater than or equal to 4.5. So that would be right here. Since it's greater than or equal to, we're going to have to color in our dot here and go to the right. And then this one is x is less than or equal to, and it's negative 0.5, so somewhere between 0 and negative 1. And we'll be shading this one to the left because it's less than or equal to. So since I have the two arrows pointing out, that means your solution is either on one side of this or it's on the other side of this. So I'm going to go back and put an or here, which indicates that our solution is either here or it's here. So then I'm just going to wipe this so that I can do the other problem. And this one, you're going to have to add 3 first to both sides before we can break this up into two separate inequalities. So I get the absolute value of x minus 3 is less than 3. So what I'm going to do now is break this up. X minus 3 is less than 3, and I'm also going to have x minus 3 flip the sign so it's greater than, and then change the sign so that it's negative. And what I'm going to do here is add 3 to both sides. So I'm going to get x is less than 6, and then I'm going to add 3 to both sides over here and get x is greater than 0. So on a number line, I'm going to put 0 here. 1, 2, 3, 4, 5, 6 would be here. So I have x is less than 6. Notice it's not less than or equal to, it's just less than. So you need to keep an open dot and shade to the left because it's less than. And then over here, I have x is greater than 0, so open dot and going to the right. So notice that if you pick any number here, let's say I pick 4. 4 is a number that is less than 6, and it is greater than 0. So that's a lot different than the problems that we had before where they faced going outside. Since these ones are pointing towards the middle, it means that any part of your solution will satisfy both of your inequalities. Suppose an elevator starts at the top floor of a high-rise building at a height of 372 feet above the ground floor and descends, so it's going down, without stopping at a constant rate of 15 feet per second. Write a function that describes the height, which is h, of the elevator after t seconds. So first thing I'm going to do here is define what my variable is here, my independent and my dependent variables. So what's going to depend on what? Well, the elevator is going to drop at a rate of 15 feet per second. So however long it travels, the distance that it travels is going to depend on that time. So your time is the independent part here. And time is measured in seconds, it says. And what's going to depend on that is the height of the elevator. So height is dependent on time, and the height is measured in feet. So notice again we have our rate here of 15 feet per second. So the rate is always going to compare your dependent unit to the independent unit, feet per second. So what I'm going to do is write a function here in slope-intercept form. So my height as a function of time, h of t equals, since we are dropping at 15 feet per second, be very careful. So we're descending. So what does that mean about our rate? It's going to have to be negative because we're dropping height. So negative 15 feet per second, so negative 15t. Plus, we had an original or an initial height when time was 0. So before the elevator started dropping, we were 372 feet above the ground floor. So that would be our y-intercept here. So I'm just going to copy that down as well. This is our y-intercept, and the negative 15 would represent our slope. So notice we are in slope-intercept form of y equals mx plus b. So we have our function. The next part, or the next thing we're going to do is graph the function. So what I'm going to do is go down to this graph. I'm actually going to kind of slide this up a little bit. So what I'm going to do here with this graph is identify that on the y-axis, I'm going to put my dependent variable, which is going to be height measured in feet. And then my independent variable was time, and this is measured in seconds. So what we're going to do here is come up with some kind of scale. And remember that 372 is going to be all the way up on top of that scale. So what I'll do is put 0 down here. And I'll count by 50s. So this would be 100, this would be 200, this would be 300, and then this would be 400. So 372 would be somewhere between 350 and 400. So I'm going to put a point here. Now what I'm going to do is count, or we could count by ones across this bottom part here. So let's do that. Let me count by ones here. Let me think where this is going to be at. Actually, let me count by, let's count by 2's here. I'm going to count by 2's here across the bottom. So 2, 4, 6, 8, 10. And what I'm going to do is figure out another point here. So in order to figure out what another point is on my line, I'm going to evaluate my function. So let's figure out how far the elevator would be after 10 seconds. So what that's going to do is give me another point, and then once I have 2 points, I can connect my dots. So what I'm going to do is figure out where the elevator is after 10 seconds. So I'm going to evaluate h of 10, which is negative 15 times 10 plus 372. So negative 15 times 10 is negative 150, and then I'm going to add 372 to that. So after 10 seconds, if I take negative 150 plus 372, it means that after 10 seconds of riding the elevator, you are at 222 feet. So what I'm going to do is go to where 222 is, and that gives me another point. And then once I have my 2 points, I can connect them with a straight line. So this indicates where my elevator is going to be. So what it says for part C here is estimate when the elevator is at a height of 200 feet. So what I'm doing for part C is giving you a height, and I want to solve for a time. So when the elevator is at 200 feet, we want to figure out what the time is. So what I'm going to do is draw a line going straight across here at where 200 feet is. And wherever it crosses where our elevator is, I'm going to draw going straight down, and I'll make an approximation. So since I counted by 2's here going across the x-axis, that means 12 would be here. So it looks like the elevator is crossing between 11 and 12. So what you're going to want to say is approximately 11 seconds. So we're using a graph to kind of just estimate where the line crisscrosses our function. So I went over from 200 feet, and then I traced down to figure out what my time is. So for part D, it says determine the exact time. So in order to determine the exact time, let's, instead of using the graph, we're going to use algebra, which means we're going to just use our equation here, our function. So if I am giving a height of 200 feet, what I want to do is work backwards. So I want to substitute 200 in for h of t. So I'm going to put 200 into the left, or substitute 200 in for h of t on the left side of my function, and notice that my variable t is what we would be solving for. So I want to know when the elevator is going to reach 200 feet. So what I'm going to do is subtract 372 on both sides. So I get 200 minus 372, and don't freak out, it's going to be a negative, 172, but notice I also have a negative on the right side. So at the very end of this problem, you have negative 172 equals negative 15t. So if you divide both sides by negative, you have a negative divided by a negative, which means t is going to be positive. So if you take negative 172 divided by negative 15, you get a time of 11.47 seconds. So notice that our guess was 11 seconds when in reality, if we use algebra, we're going to get that exact answer. And the time ends up being 11.47 seconds. So algebra is the more reliable method to use when we're substituting in. Rather than using the graph, we're able to just do an approximation. For this one, we're going to evaluate a function for a given input. So evaluating f of 6.2, all that means is that since it's f of x, what you're doing is taking 6.2 and you're substituting it into your function for x. So f of 6.2 equals 31.572 times 6.2 minus 17.741. So I'm going to perform the order of operations here. 31.572 times 6.2 is going to give me 195.7464, and I'm going to subtract 17.741 from that, and that is going to give me an answer of 178.0054, and that would be where your function is at 6.2. So if I were to express this as a coordinate, when my x value is 6.2, my y value is 178.0054. So you're using that function notation to determine your inputs and your outputs. So my input of 6.2 here for x would give me an output of 178.0054, which is my y value. For these ones, we're just going to evaluate absolute values. So first here, you wanted to perform the order of operations. 4 minus 12 is going to give me negative 8. And since absolute value is basically saying how far is negative 8 away from 0, it's positive 8 units away from 0. So that's what you end up with. For part B here, again, order of operations on the inside, negative 8 times 7 is negative 56. And the absolute value of negative 56 is positive 56. And then the last problem. The cost per family to join a swimming pool is $375. In order to get the pool ready for summer, renovation and painting are needed each spring. The pool asks members to help complete the work. So for every hour that the family member works during the spring, the pool is just going to reduce their membership fee by $10. So it's kind of like the people are making $10 an hour just to do some maintenance work. So what we're going to do here is determine basically our independent and dependent quantities. We'll have some units here. I will write a function for this, and then we'll actually just evaluate. So what the family really controls here is the number of hours that they are working. So the time measured in hours that the family works is going to save them some money. So then what depends on that is the cost of their membership, which is, or not the membership, the cost for the pool, which is going to be measured in dollars. So however many more hours they work, their cost will decrease on that pool then. So what I'm going to do off to the side is just write my function. So I know that we are saving $10, so that means that their fee of $375 is going to keep dropping $10. So what I'm going to do is write this in function notation. I'm going to say that C is going to represent the total cost for the family, and I'm going to say that T is going to be the number of hours that the family works. So the more they work, the cheaper it is. So a function, C of T equals, now we are dropping the membership fee by $10 every hour. So that's negative $10 per hour plus my y-intercept, which would be $375. And again, I know that's the y-intercept because if the family doesn't work at all, if the family says, I don't feel like working on the pool at all, they're just going to have to pay the $375. So that means that I could even fill in this value on my table with 375 because if the family doesn't work, they're not going to save any money. If the family works 2.5 hours, what you're going to do is substitute 2.5 in for t. So I'm going to take negative 10 times 2.5, and I'm going to add that to 375, and that means that the family would only have to pay $350. So what I did is substitute 2.5 in for t, and that would give me my corresponding cost. So what's different about the bottom one is that I'm giving you the cost, and we have to work backwards to figure out the time. And that's very similar to the problem that we did on this slide, where down here in the purple we had to substitute a value in for our h of t for a height to solve for time. We're going to do a similar thing here, where I'm going to substitute 305 in for c of t. And what we're really determining here is how many hours the family would have to work in order to only pay 305 instead of 375. So I'm going to subtract 375 on both sides. So just doing a little algebra here, we're going to take 305 minus 375, and that's going to give me negative 70, and I'm going to set that equal to negative 10t. So then what you're going to do here to get t by itself is divide both sides by negative 10. I'm going to squish it in there. Negative 70 divided by negative 10 is positive 7. So what that means is if the family works a total of 7 hours, they will have saved $70, which means they only have to pay $305. So reviewing, going back, everything that we've done then, we solved equations, we solved inequalities, we solved absolute value equations, absolute value inequalities. We used a graph and a function to determine some inputs and outputs. We evaluated a function at a given input. We worked on absolute value problems, and then we ended up identifying what dependent and independent quantities were, writing a function, and then evaluating it to complete a table. And that is everything.